So we have generally the goal of this breakout session is to obtain the science community input uh, on the specific topic and how can we on priority lunar physical sciences, technology and capabilities, needs and collaboration. And the objectives are what are the top priority physical sciences knowledge gaps and research topics that must be considered on the moon or in the cislunar orbit in order of priority to enable sustained lunar habitation and future Mars mission, and which of these need to be initiated in the near term for the next 5 to 10 years, and what meaningful science that can be conducted on the moon given its unique environment of reduced gravity, vacuum, and temperature radiation, and what are the key technologies, technical capabilities, and resources needed to conduct physical sciences research. So we will start with the first question. And give me a second. Okay. I mean, as of now, in the first session, we actually, the question that some of the big gaps that I'm paraphrasing it. So Tyler, if I'm missing something, please let me know. Is one of the question that came up is like, what is the lack of the available? So we have lack of available facility. Like on Earth, it's very difficult to create a lunar gravity situation, which is large enough to do large scale experiment. The other question was like the existence of the water, like how it is, where it is, which format it is there, and there is a knowledge gap in that regard. So Tyler, am I missing anything? If you are back, anyways, maybe
Yeah,
you.
just
Yeah,
give
go
me a second to scroll back up to it. Um, yeah, we also talked a little bit about some of the team building. What is the best way to build a team for, say, an NRA response or like a proposal to a CLIPS lander experiment or something. That's kind of where the diversity talk got started, was in there as well. But you covered everything else.
Okay. Yeah, no, I'm talking about like the single, like the big gap over. Oh yeah. Okay. I got it, Tyler. What you were
Right.
saying.
I
So
don't think that's a gap, but that's one approach to help
yeah.
pursue research in this area.
And Ben and Mohammed, you guys have any thing that you think you would like to say in that regard, with regard to this question?
Hmm. Sorry, what was that?
So Ben, I mean, so with regard to this question, like what are the top priority physical sciences knowledge gaps and research topic that must be conducted on the moon or in cislunar orbit in order of priority to enable sustained lunar habitation and future Mars mission? And what do you think that needs to be initiated in the near term for the next 5 to 10 years?
I see. Um, well, so I'm not necessarily the best authority on this because I've only been working in the field for several years. But I've been working in dust and regolith research, and it seems like there really is a huge knowledge gap in the understanding of the effects that lunar regolith has on the human body and on just equipment that we send into space. There's also a big gap in knowing how to actually deal with that regolith and so on and so on. So based on my limited knowledge as far as lunar sciences go, it seems like and this goes for Mars as well, that understanding the actual environment that we want to be working in is a huge thing that needs to happen. As far as like actually building teams to address these problems, it needs to be a good balance between biologists, engineers, physicists, just everyone who actually has their own unique input on it.
So then, if I kind of rephrase what you just said, are you saying like the knowledge gap is because it's a multidisciplinary activity. So that is why there is not a lot of intermixing happening between different disciplines. Is that what you were saying?
Sorry, one more time. My audio is not super good at the moment.
No, what I'm saying is like, are you saying that because this research is such an interdisciplinary activity, but still there is not a lot of intermixing between different disciplines happening? Is that the knowledge gap you are saying?
It does kind of seem that way to me because I've met a good number of people doing fundamental research, but not really that many folks doing more practical, like engineering based research and work regarding like lunar regolith and things like that. So it does seem like it's more, there's a lot more work being done on a fundamental level, but not really at a practical, how do we actually deal with this?
Okay. Others? John, Mohammed, any of you? You guys are speaking. I cannot hear you. Maybe because you are mute. So maybe Ben. Yeah, go ahead.
Suman, I could add to that. I wonder if it's just because we're in such dissimilar fields that we don't have any existing connections for building those type of teams. I mean, is that something we could address through like a mixer event at the next Lunar conference or something like that? That might be useful to help address that gap. I know other conferences have done similar things like that.
Yeah, I have been to other conferences where they specifically tried to bring people from different fields of expertise together, and I think something like that could actually be really useful and fun. And actually, this conference already, I found there was a lot of good diversity in my I think it was the concurrent session 1. I found that there actually were a wide range of people, which is really good to see.
So maybe Ben, let me. So first of all, Tyler, I think that's something that we need to talk with Fran and Kevin, Lisa, for that matter. Is like how we can execute that. My suggestion in that regard, and you guys please tell me if it is wrong. So which is, I think instead of saying I did this, maybe an opposite is like I lack this knowledge and that is what I'm looking for. That type of a session might be very important. Like, so what I mean is, like, instead of the researchers coming up and saying what they have done, the research, so there might be one session which just says what are they lacking.
I would agree, because that invites someone to jump up and say, "Oh, I know how to do that," or something like that.
Okay, so maybe, yeah, so that may be a suggestion, Tyler. Maybe we can make to Kevin and Lisa in that manner, and maybe we can. It will be almost a negative conference meeting. It's like people not presenting their report and everything. Opposite of presenting is like asking for more ideas or collaboration in that manner. But Ben, with regard to that, like if we kind of build onto that from your perspective of working in the field of Regolith, and so where are you seeing, like what are, like specifically speaking, what research topics you feel are very important? Maybe because I understand what you just said, but specifically speaking, what do you see lack?
Well, I guess that's kind of hard to pin down. I guess specifically, I work in mitigation, so dust mitigation. That's what me and my group are working on. And I guess the the area that I'm probably seeing the most, need for more diversity is just, oh my, sorry, I'm trying to figure out how to say it. Sorry, I'm having a little bit of an issue formulating what I want to say. I guess here's what I would say is there seems to be a lack in fundamental research as far as how the regolith actually interacts with equipment. That's probably going to be the biggest area that I've seen a bit of a disparity is that nobody really seems to know exactly what the adhesion is between different dusts, and no one necessarily knows. And there's like big differences between different types of dust and different regions of the moon, and a lot of people don't seem. It seems like there's not that much knowledge as far as how the dust actually interacts with the equipment that we send to the moon, and that's where we're running into some issues, because you can't really design, you can't engineer around that when you don't know anything too well. And that seems to be a bit of an issue.
So, for example, that could be like a crane or a drill or something. We don't know how the dust will impact that. Like if we're drilling into a rock, it could clog up sooner, or something more expected, stuff like that, right? If we're trying to get water ice.
Right, exactly. And things like drills, things like space suits, lenses like camera lenses. And that sort of stuff, it's all really important. We need to send it up there, but it's kind of hard to figure out how to protect it when we don't really know how it actually interacts with the environment.
So to sum it up, Ben, maybe is like the very basic idea of doing this study, the basic science, is almost obscured by the problem of dust and everything.
It kind of seems that way. Because I've been working on a dust mitigation project for several years now with a group, but and I'm guilty of this too, because I've never once tried to figure out exactly what is happening between my simulant and my material. I'm mostly concerned about how much of it I can get rid of. And then anytime I talk to someone else about it, they say that it hasn't really been looked at too closely.
Okay, so that's a good point. So others, John, Heather, Catherine, Alexander. So while I have you, Ben, I will send you an email offline. I wanted to talk with you about that, some other things. So please look out for my mail too much, and can talk more in detail offline.
Yeah, of course. I'd love to talk more.
Sure. So anybody else has any more any comment on this regard? Okay. If not, then we will move to the next question, which is what meaningful science can be conducted on the moon given its unique environment of reduced gravity, vacuum, temperature, and radiation? So in the previous session, some of the questions that we kind of jotted down. One is the rheology is one of the challenges. And Tyler, if I miss something, please chime in. One is the rheology, meaning, so for example, how this granular media or like whatever rocks and etc. in which the water and the ice is trapped, how can we actually handle them? So that meaningful science is going to be very important. The second part is, which is kind of the something that when you referred to in the first question, which is how do we initiate, like how the multidisciplinary science part of it we can actually execute. So for an example, there are questions from the fluid physics side, from the complex fluid side, the geological people, or people who do satellite imagery, and some people who do characterization. So how do we kind of different all these people, like almost this, that I lack these type of question can be asked, and that meaningful science can initiate like a collaborative environment between different disciplines. And the other question was like, uh, which based on like three question is like what is the form of earth and where, sorry, what is the form of water, where the water is stored and how it is stored on moon, and how can we simulate such a environment on earth. So these were the three things I remember. Tyler, did I miss anything in addition to that?
Yeah, you got it.
Okay. So with regard to that, so again, so what I mean by that is what meaningful science over here is, if moon is this unique place, what type of science that from your perspective that you guys think can we do over there that can facilitate this water extraction process? So Ben, I will ask you one more time. Are you saying something, Ben? We cannot hear you.
Oh no, sorry. I'm trying to think. So what kind of science can we do to try and facilitate a meaningful science? That's a great question. I feel like I was unprepared for the breakout session.
No, that's fine. Yeah, we are chatting. Please don't feel pressured. I mean, just chatting and this maybe answer from your perspective, the type of stuff that you do from that perspective.
Well, I guess if the topic is water, I don't necessarily have anything to say as far as finding it, but I think it would be really interesting to try and figure out good filtration methods relating to filtering the dust or filtering regolith out of the dust. Because I've seen some presentations and talks within the last couple months where some biologists actually were researching the effects of very small scale lunar dust on human lungs and nervous system and all kinds of things like that. And they were researching particles as small as nanometer size. So I think it would be really interesting to try and filter whatever water we had. If we find water and if we find a way to grab it, it's got to be processed and filtered in such a way that there's absolutely no regolith left in it at all. So that'd be kind of interesting.
Like this microfiltration, but now you are touching water.
Say that one more time. Sorry.
So I'm saying like almost like an ultrafiltration or regular filtration process that people use,
Yeah.
or desalination plant type thing. But in this case, you are literally squeezing stone to get water out of that.
Hmm. Okay. Okay.
I'm just analogy. I'm giving an analogy on a little. So is that what you are saying? Is like how do we kind of enable innovative filtration process to separate water out from whatever format it is like attached to?
Yeah. Kind of. Kind of.
Okay. So anyone else? Okay. So we can go to the next question, which is this final question. What are the key technology, capabilities, and resources that we will need to conduct physical sciences research on the Gateway and the Moon, like Eclipse lander, Artemis vehicle, lunar base camp, etc. And some of the things that came out in the previous session, which is almost like a self-automated experimental box, which will have. So the idea is because there is so much trouble with dust on lunar surface, we cannot expect the crew over there to conduct the experiment like they do in ISS. So there need to be a self-automated experimental block almost. So where and we can perform different experiment that can run on its own, or we can control them from here, those experiments. Some of the other thing that were also mentioned was like, for an example, different spectral characteristic. So like which can go on the rover, like near IR, which they already have, or like XRD and things like those. Um, so that was the another thing that was mentioned. And on the format of utilizing like granular media, like how you can handle them, meaning almost an on-board rheological characterization process. So that's what was described in the previous session. So anything else that you guys think?
And Suman, you kind of you kind of mentioned it briefly, but I think one of the most useful things we talked about earlier in this third question was some of the instrumentation. Let's see, I'm just looking at my notes back here, but yeah, like Paditha mentioned, chromatography. Let's see. We probably don't need a microscope for some of these experiments at this stage because we could just bring it back to Earth. But spectrometers are really important. And I think someone mentioned Viper has a few of those, which is an existing lunar lander. And that can open up some of the rheological experiments and other things of that nature. But yeah, I think hardware is a good way to approach this question. If anyone has thoughts on, what types of instruments might be needed.
Yeah, so I kind of very briefly mentioned Tyler. I just mentioned from the viewpoint of a characterization. Thank you for clarifying.
Right. Yeah, just wanted to throw a few examples out there.
Okay, thank you. Anything else? So Ben, anything you think? Also,
I can't really actually think of anything that you didn't already mention. Because you guys already mentioned quite a few different instruments, and I will say that I really like the idea of trying to automate all the experiments as much as possible. There's no reason astronauts should have to do anything if a computer can do it. But
Hey,
otherwise,
Ben.
no, I don't actually have too many suggestions.
Hey, Ben, I did have a question about something you mentioned in question 2, or maybe it was question 1, about how dust can impact the camera lenses.
Mhm.
So if we're trying to, use one of these instruments and we need visual or some other type of, not visual, visual or maybe IR or something, but we need a camera lens for that. Do you know, like, I don't know if sapphire would give you any better properties, for defending against lunar dust if it ends up being a camera that's exposed to try and look at some of the rocks where we may think ice is. But have you guys worked with that at all? Like, are there any lenses that really allow for more research and mitigate some of the dust, just purely from like a mechanical standpoint, or maybe there's some type of coating that works or something like that?
Well, if you're thinking of like a passive method to try and just keep the dust from sticking to the lens in the first place, I know. So I don't specifically know about any coatings or films or anything like that, but I know there are other groups that are working on that for camera lenses specifically, I believe, so that it just keeps the dust from sticking. Um, but so I guess with camera lenses, part of the issue is that the dust will get on the lens and scratch it, and that ruins the lens. Um, but then the other issue is that it just covers up your image, and you can't see anything. So I guess in the past, what they did to get dust off of instruments is they just brushed it with basically a paintbrush, and you couldn't do that with a modern camera lens because that would just scrape the dust all over the lens and ruin it. So you would I think a combination of passive and an active mitigation. So first off, try and coat the lens in something that's scratch resistant and also less adhesive to the dust. I'm not quite sure what that would be. And then in addition to something passive, probably have another method for mitigating the dust, either like a little compressed air nozzle that regularly just blows onto it, or my group is actually working on an electron beam technology that can remove the dust as well. And either of those methods would prevent the dust from sticking, and they would remove it, but it would also avoid scratching the lens because it wouldn't just scrape it across the surface.
Couldn't you additionally also put a light film covering over the lens and then apply the mitigations to the coating that's over the lens? So that way you've got a barrier between the lens and whatever it is or whatever else is sticking to that covering or that coating.
Right, that is absolutely true.
but in that regard, like irrespective of whatever coating, that coating may work perfectly fine over here, but there is not a great guarantee that it will work.
Well, but the thing is, the coating is something that it's kind of like with our watches and with our phones. We apply a layer and we can remove it and we can apply another one. I mean, that's just a thought.
But then there may be another way in that regard, which is almost like the way the action cameras do the stuff. What I mean by that is like if you take a look at like a GoPro camera, they are like housed in a very sturdy box, like chronometer and things like those. They can stick in there. So essentially, you take the dirt and you kind of almost like hop it in, and the camera almost sitting in a covered chamber, almost like a GoPro type thing.
That's another process.
Yeah, and in the like take the action camera out. So and then just if anything, you instead of thinking about the lens, you just can toss up those boxes. Almost like there must be some way of doing it.
Yeah, protect the entire camera because dust gets in every nook and cranny when you think about it. So that's also a good thought process as well.
Yeah,
You have to think,
I mean,
you have to think of Eclipse with a camera.
Right, right, right. So yeah, so in that regard, so I think because the challenge what I was thinking is I think Karen was mentioning in one of the um, session, and the van der Waals force will be extremely high. And they can pretty much stick to anything at that gravity, and the porosity also jumps up.
Mhm.
So as a result of that, the dust can actually stick to almost anything. I mean, that's just my viewpoint. I mean, I may be wrong.
no, I mean, dust can stick to just about anything. Some things it sticks harder than others, but pretty much anything is gonna collect dust over time. Um, and what y'all were saying about basically just putting the camera into a case, kind of like we put like underwater cameras in a case. I think that would have to be done. And then if we could come up with something because even the case, that still requires that, periodically an astronaut comes and cleans off the case.
Mhm.
No, I think then I'm not saying that. So I mean, think of like almost a hybrid situation between an ACM chamber, a scanning electron microscopy chamber, and your regular camera. What I mean by that, you take it and then you kind of almost put it in a small chamber, you lock it, and then you visualize it from a distance. That's what I'm saying. So you are not just looking as you go. You almost like sanitize it before sanitize it, meaning that you do not just bring it to the contact of the stuff immediately.
Are you talking about airlocking the camera?
Kind of.
Okay, that makes sense. Uh, what exactly? What would be walk us through the steps of what you're talking about? You know, step by step of what you're thinking, because I think I'm visualizing what you're talking about, but I want to get the whole process.
Yeah, so I was thinking like if you think of putting a sample in an ACM chamber, right? So there is like a pre-vacuum, and then the pre-vacuum opens the ultra-high vacuum, right? And in that manner, so it's pretty much like you take almost like a copper tape, like or a double-sided tape, and then you use that to scrape up that stuff, and then you put it in a chamber which is a little vacuum there, and the vacuum whatever could fly, it flies out, and you collect it separately, and then you bring the camera in. So instead of, in case of an ACM, the low vacuum and then a very high vacuum, there are two stages. So in this case, you don't go to a very high vacuum, you just stay it like 10 to the power minus 1 torr or something like that, and you use a double-sided tape to just pick up the dust.
Okay.
That's just a thought process. So in that way, whatever analysis you want to do, you do it on the background of a double-sided tape.
I see. That actually makes sense. It sounds like a pretty good idea. You're just bringing the sample to the camera rather than the other way around.
Exactly. Yeah, and that helps to explain the process to understand it. Yeah. Mm-hmm.
Yeah.
So use the very basic thing, ACM, TEM, they all use, which we know. And because whatever fly, let it fly, vacuum chamber, and then whatever sticks, and we do our analysis on top of it. I think it will be much faster, and we do not have to then worry about a lot of stuff. I mean, cheaper also.
Yeah, cheaper.
Well, it's also easier on the astronauts too.
Yeah, yeah. I mean, you can literally have like thousands of stub, for lack of better terms, which have like a double-sided tape on it. You just kind of take it out, and then you touch to the surface, you take it, and then you put it into the chamber. I mean, I'm just saying, like, it can be designed that manner. So,
Yeah.
or even they don't have to do it. It can be done by like the rover or any automated instrument.
And Suman, I think that's been done on some of the Mars rovers missions. Like every now and then, some of them will do an in situ measurement of, like, say, I don't know, chromatography or something in a rock, and they'll just analyze it in the air. But I think, especially for like the sample returns and things of those nature, they'll actually extract a piece and then bring that in a closed environment within the rover and do some testing there, all within the rover. So that's probably a better approach to it.
Yeah, you can do it this way also. So you can almost have like a cartridge, stub meaning like the small plastic or whatever the holders. You can almost stamp them, QR code them, or you can have like a number on the side of it. Just take the picture and do everything, and then you throw it in to the bin, meaning like you store it, and those you can always bring them back and you can match according to the numbers of where you picked it up and things like those. So I'm just saying, like, if the dust is an issue, that maybe we just separate the instrument from the dust.
I mean, that actually does seem to be one of the better ideas, and that's where people are. That's where the thought process is going for other things too. Is just to have, multiple chambers or airlocks or something like that, just to leave the dust outside, and then we don't have to worry about it at all.
Yeah.
Yeah. Because there really is no way to completely get rid of all the dust, no matter what you're trying to do. So
Yeah,
if you
because
can just.
I was looking at one of those images that Karen was showing today morning, and the amount of like almost tentacle type thing that they have, even on a, so I'm pretty sure the van der Waals will be like crazy high. So meaning they will stick to anything, almost like a gecko. You know what I mean is. So and on top of that, I mean on top of that, and they are irradiated, meaning I'm pretty sure they might be charged also on the surface. I do not know if that will be the case, meaning they're, because they are always getting this radiation from space, right?
Yes, they are
So
going to be charged.
there must be some accumulated charge on top of it. So almost like a static charge on them, and then that will help them to sticking. I'm just assuming. I do not know, but
No, that's correct. The dust particles actually do carry a lot of charge because they collect it from the radiation from the sun. They collect it just from like rubbing up against each other. They collect charge, and that helps them stick to everything.
I mean, and in this way, with this stub thing, what I was mentioning, Ben, and maybe is like it's essentially like this is the same idea that electron microscopy used to get rid of any excess charge, right? So you have like almost a conductor surface, and you ground it out, and you grind it out. So. So. Okay, so that's I did not think about it before you started talking.
No, it's interesting, and I think that would work. It would also be pretty easy to scale up for different experiments, different size samples, because it really is a simple idea,
Right.
Which is always nice to be able to scale it.
So anything else? Okay, so if not anything, so Tyler, maybe do you want to just paraphrase everything that we talked about?
Yeah, so I'm just gonna go over this session. So going back to question 1, we kind of talked about the teamwork aspect again, and then Ben mentioned how the fundamental work is great, but we also need some practical work to help supplement that. And then we talked about maybe doing a mixer to help bring together those teams, and I'll bring that up with Kevin later. And then Suman, you mentioned maybe doing a conference or a similar meeting on what do we lack rather than what have we done in our labs. And that might be good to do as well, just to help really drive home with some of the ideas. And then Ben mentioned some of the, we really don't have a good understanding of fundamental properties, mainly relating to dust, but how this interacts with some of the other equipment, like relating to water ice. It could be an extractor crane or a drill or something of that nature. That's where the camera lenses were first brought up. And that can obscure some of the basic processes we're trying to do on the moon. I didn't get anything for question 2. I had to step away for a second, but we can go over that later. But for question 3, the discussion was just about, I had the question about how this affects your camera lens. If you're trying to drill for water ice or something in a rock, and your camera lens gets covered by dust, how will that affect it, or how can we prevent that? And he said we used brushes before for some other stuff, but the best way to do it is a combination of both active and passive mitigation. So things like air nozzles, and that might help. And then I think it was Beeb or Bebe, she mentioned using a film covering on the lens as well. There was some talk about van der Waals force, and it might be better just to extract a sample and then analyze that in a container, and have your whole camera enclosure kind of like a GoPro, or have an airlock there, something like that, rather than doing an in situ measurement. Yeah. Did I miss anything on question 2?
Yes.
Down?
So the question 2, so one of the things that was mentioned was that how an efficient filtration process to separate water out more efficiently. So meaning, because the water will have a lot of other stuff which we don't want. So how do we have a better filtration process?
Okay.
Okay.
Yeah, I think we got everything. Lots of good discussion. Did anybody have anything they said or comments you'd like me to add that I may have missed?
Mohammed, if you are saying something, we cannot hear you. You are mute.
Yes. Well, actually, like I was thinking about the exploration of ice or water on the moon. Like as I noticed today, many of the speakers they mentioned that, and I don't know. Like for me right now, like as a PhD student, I was thinking, I don't know, guys, if you can recommend that. Does it worth to work on such research? There is available like any available data right now, maybe to work on or something. I don't know, like if you can recommend something about that.
Sorry, can you repeat the last part of the question one more time?
Well, like I mean, if you can recommend, or like maybe if you can share your thoughts with me now about the exploration of water on the moon. I mean, like many of the presenters, they mentioned that today, and I was thinking to work on this part. But to be honest, like right now, actually, like I'm working on dust particles in Moscow, in my MIPT in Moscow. But the topic of the ice and water on the moon, I don't know, like it's quite interesting for me, but I'm not sure if it's worth to take the risk and start such a research right now. I believe that there is a lack of information in this part. but maybe you have you can add something maybe to that.
Yeah, I'm not aware of any myself. I know we do have different repositories out there, you know, for physical sciences data, mainly for ISS experiments. And Kevin Sato mentioned in the first part of the breakout that for some of the like the gene-related experiments, they do have their own repository for that, you know, for helping researchers to getting multiple researchers to look at the data. But um, yeah, I'm not aware of any, unfortunately, off the top of my head. And you know, large repositories or freely available type of data on that. I think a lot of it is either only strictly peer reviewed right now, or just really hasn't been published yet because it's still a pretty new area.
Yes, I agree. Actually, that's why, like, I don't know, like, I was hesitating about it a little bit. That's why, just like, I wanted to mention that question with you. But yeah, thank you. Like, of course, I understand that.
So anyone, anything? Heather, Catherine?
I just had one quick thing. I came in at the very end, so I think there was probably a lot of things already discussed that I likely missed since I was in some of the other sessions. So I apologize if this was already addressed in some way. But in one of the other sessions, I was just asking about, or a topic in the material session was brought up about how off-gassing, if things are not completely off-gassed, it can be an issue. For if those get deposited on radiators or solar panels or what have you. And also what I was wondering related to the dust is, because I was asking some questions about, you know, could we use the natural vacuum for material production of using regolith to produce a material similar to growstone, which is a growth media. But I'm wondering if the combination of off-gassing, you know, if you had volatiles that, so in the growth media, they use like a foam, it's like a foamed glass. So you have to use a foaming agent. So I don't know if it would be an issue to, you know, with the dust to have that be combined and then make that, you know, the deposition problem even worse. That wasn't a fully coherent like question, but I guess what I'm trying to get at is it possible to use the vacuum, and does dust become a bigger problem because maybe you're in this manufacturing process, you're producing more dust plus you're adding VOCs to it, and then if that's deposited on radiators. So is it really just infeasible to use the vacuum for doing that kind of a process?
So maybe if I kind of rephrase, Heather, what you said is that, are you saying like you think one of the topics of the research can also be, or like, let's come back, share my screen, give me a second. So this is the knowledge gap, like what is the impact of gassing you have with regard to water extraction? Is that what you are is that the question?
Yeah, that could be part of the question. And sorry, I thought I was in the dust session. Did I rejoin the water session?
Yes.
Oh, well, that would be why that question made no sense. Although it is sort of, so let me reframe it in the water side of the question. So, if we were, and I apologize because I thought I had clicked on the dust session, but so if you were creating this growth media out of regolith where you've done this foaming process, and if you have, you know, I guess if you've already, well, let's say you're already past that, you've manufactured it, you've now used this growth media, and you wanted to reuse it, you've already had plants growing in it. If you wanted to reuse it, actually the other topic I had mentioned in that other session was, could you use the vacuum to sterilize the media and reclaim some of the water? And so I think, I guess it would be more related to, how could you reclaim the water from the media and use the vacuum at the same time to sterilize it, if that's feasible. I guess that would be an experiment that would be useful to know, because usually another way to sterilize would be heating, but of course that takes more power. So if it would be possible to use that vacuum and reclaim the water at the same time, then that would be a good technology to look into.
So what you are saying is like, so the whole idea of a vacuum mediated off-gassing, can we utilize that to actually recollect the water? Is that what you are saying?
Yeah, basically.
Okay. So that goes into the gap. So because that is the type of the question, like we do not know how we can actually utilize the local environmental condition to in favor of water extraction, aka off gassing or like the vacuum gassing. Anything else?
Nope, that was my only thought to add.
Okay, thank you, Heather. Catherine, anything on your side? Okay, great. Okay, so then I think we are pretty much done. We still have like 6 minutes. Tyler, do you think we should close up then?
Yeah, I mean, it's up to you. I know the one I was in with John yesterday did end a few minutes early, so I don't feel like we need to keep people.
Okay, sure, absolutely. Okay, so in that regard, I guess thank you all, and these were really helpful. And again, if you have any question or anything that comes up to you, let me share my screen. Give me a second. So these are our contact. So this is me, and this is Tyler. I'll leave it open for till the end. So if you want to reach out to us, please feel free to reach out to us. Send us an email, and if you just like, oh shoot, I completely forgot about this, I should have told this, please email us. We will take care of it. And so with that, so thank you all for coming, and thank you, Tyler, for taking all the notes. And so have a nice day, and hopefully we'll see you guys soon in some other forum.